Temperature is one of the basic elements of weather and climate. It's likely that if someone were to ask you what the weather's like outside, air temperature would be one of the first things that come to mind. Our objectives for today are to identify the factors that influence temperature, describe how the heating of land and water differ, and explain the effects of cloud cover on temperature. A temperature control is any factor that causes temperature to vary from place to place and from time to time. We talked about temperature variations earlier from the amount of direct and indirect sunlight that we receive when we did the lab. So that would be here under latitude. So depending on your latitude or where you are on Earth, our temperatures might vary. We have a couple other things that cause variations in temperature: heating of land and water, altitude, geographic position, cloud cover, and ocean currents. Just like the lab, to review here, at position A, our temperature is going to be colder because our sun's rays are traveling a longer distance and they're at indirect rays. At position B, down here, our sun rays we have direct sunlight. If you remember from the lab, the squares down here were small while they were all stretched out here. So latitude definitely plays a huge role on both our seasons and the temperatures that we receive at those times. The heating of Earth's surface controls the temperature of the air above it. To understand differences in air temperature, we have to look at what the surface is made up of. Different land surfaces absorb different amounts of incoming solar energy. The largest contrast, however, is between land and water. Land heats more rapidly and to higher temperatures than water. But land also cools more rapidly and to lower temperatures than water. Temperature variations, therefore, are considerably greater over land than over water. If you were to think about it, in Colorado, we're not close to any large bodies of water, so our temperature varies greatly. Plus, we're on the Front Range, so we get all those weather patterns, but it can be freezing in the morning and 60 degrees at noon. If we were in a place near water like San Francisco Bay or Hawaii, Hawaii's close to the equator, so that doesn't really count, but our temperature variations are going to be less because that water is going to control the temperature. Temperature variations in the northern and southern hemispheres are compared in this graph here. Water accounts for 61% of the northern hemisphere and land accounts for the remaining 39%, whereas in the southern hemisphere we have 81% of the surface is water and only 19% of the surface is land. So if we look at this graph here in our tropical regions, our average is fairly consistent, and then over here in the north, our temperature variations are going to be very great because we have more land, whereas in our southern hemisphere, this is our degrees south over here, the temperature variations are less because water accounts for more of the surface area in the south. In this graph, the same thing is being shown. In a dry city, the time of day, our temperature starts really low and increases and it gets really hot, and then at night it drops down. This is typical of deserts. During the daytime, we get very hot in the desert and it's very cold at night. Whereas in our humid cities or somewhere near water, our temperature does change, but not quite as drastically. The reason behind this again is that our temperature on land absorbs that heat really fast, but good absorbers are also good emitters, so then as it absorbs it, it's going to lose it at the nighttime. The geographic position or setting can also greatly impact the temperatures of an area and cause weather patterns based on the wind. So if we look at this, our windward coast is going to be where the wind blows from the ocean onto the land. So it's carrying this moisture from the ocean and bringing it up on the land. This is a picture of the windward coast on Hawaii, which is over here. In the windward coast, you'll notice that it's green and lush, lots of moisture. The temperature here stays pretty consistent, very moisturous. Whereas on a leeward coast, the wind is blowing from the land off into the ocean or over here. This is on the west side of Hawaii. And the land is going to look much drier because it's not getting that moisture from the ocean. Altitude is another factor that can change our temperature variations or affect them. As we have an increase in altitude, we're going to have lower temperatures, and vice versa. If we decrease in altitude, our temperatures will be warmer. Picture of Pikes Peak here. If you've ever hiked to the top of Pikes Peak, you know at the top of it, it's much colder. We can see the snow capped up here. Whereas at a lower elevation, down where we live, the temperatures are generally warmer. This is why your cities that are close to the coast and at the same latitude are warmer than cities that are on top of a mountain. Cloud cover and albedo also affect our temperature. Albedo is the fraction of total radiation that is reflected by any surface. We talked about this in class a little bit, but like snow has a high albedo, which is why you have to wear sunscreen when you're skiing. So as solar radiation comes down and hits the snow because of its light surface, 80% of that radiation is going to get reflected back up at your face. Whereas things with a darker color absorb more of this sunlight and reflect less of it. Many clouds in the sky have high albedo and therefore reflect a significant portion of the sunlight back into space. So when there's heavy cloud cover, we're getting a lot of this and none of our solar radiation is coming through to Earth's surface. Many clouds have a high albedo, so they reflect a significant portion back into space. During the daytime here, if it's a cloudy day, our clouds have a high albedo, so they're reflecting all of the solar radiation back up into space, allowing a little bit to get through. Whereas if we've had a sunny day with very little clouds, all of this solar radiation is going to come down and be absorbed by the ground, thus increasing temperature. At the nighttime, if there's clouds, the clouds kind of act like a blanket, and the albedo of the clouds, as this ground is cooling and radiation is going up, it'll hit the clouds and it'll come back down. So during the nighttime, clouds help warm the surface, whereas during the daytime, they're preventing heat from getting in. Going back to our objectives, you should be able to identify the factors that influence temperature, describe how the heating of land and water differ, which is one of your conclusion questions, and explain the effects of cloud cover on temperature, another one of your conclusion questions.